In this problem, we need to find out the value of the following trigonometric ratio. Let's begin with problem number 1. So here we have cosine of 855 degrees. But what we'll do, we'll try to rewrite 855 degrees as a multiple of 90 degrees. For that, all we have to do is take 855 and divide it by 90. Now we know that 90 times 9, so that gives us 810. So that means we now have a remainder of 45 degrees, meaning we can express 855 degrees as 9 times 90 degrees plus the remainder, which is 45 degrees. Fine. So writing in this fashion, we can now easily compute the value. Here we have an odd multiple of 90 degrees. So whenever we have an odd multiple of 90 degrees, then cosine transforms to sine, and the angle will be 45 degrees. We'll also have to take care of the sine. For that, we'll go to a quadrant system. So first, let's look at 9 times 90 degree. That means we are in the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. So ninth quadrant means we are back in the first quadrant, but we are adding 45 degrees to it, which takes us to the second quadrant. Now in the second quadrant, only the sine and cosecant are positive, and everything else is negative. But you don't get confused because we have a sign here and we will get positive. No, it's going to be negative because we always have to focus on the original function. So we started with the cosine function, and in the second quadrant the cosine function is negative. That means the value of the cosine will be negative. Now we have sine 45 degrees, so that's 1 over square root of 2, which gives us a final value of negative 1 over square root of 2. Let's go to the second problem. The second problem, we now have sine 1845 degrees. So what we'll do, we'll take 1845 degrees divided by 90. So this can be also expressed as 20 times 90 degrees. So that's 1800. We are still short of 45 degrees. So we add 45 degrees to it. Now we have sine 20 times 90 degrees. So here 20 represents an even number. So our sine function will remain as sine. So we have sine 45 degrees. Now we have to check in which quadrant it lies. So we are in 20. The 20 means we will be in our fourth quadrant, since 20 is a multiple of 4. But then again, we are adding 45 degrees to it, which will take us back to the first quadrant. But luckily, everything is positive in the first quadrant. So our final value is going to be 1 over square root of 2. Let's do the third problem. So in the third problem, we have cosine 1755 degrees. So let's try to break it down. So we will have 20 times 90 degrees. So that's 1800. So we are exceeding 1755 by 45 degrees. So we're going to subtract 45 from it. Now we have cosine of 20 times 90. So that means we have an even multiple of 90 degrees. So cosine will remain as cosine. We're going to have cosine of 45 degrees. Then in terms of quadrant, we will be in the fourth quadrant, because in the fourth quadrant we have a multiple of 20, but we are also subtracting 45 degree to it. But luckily 45 degree being an angle less than 90 degree, we're still going to lie in the fourth quadrant. Now in the fourth quadrant, cosine function is positive, so we're going to get positive cosine 45 degree, and this is going to have a value 1 over square root of 2. Moving on to the fourth problem. Now we have sine 4530. Now we have sine 50 multiplied to 90 degrees. So that's 4500, and we are still short of 30 degrees. So add 30 degrees, and this is going to give us 4530 degrees. This time we have sine an even multiple of 90 degrees. So sine will remain as sine, and the angle will be 30 degrees. Now we'll have to look in which quadrant it lies. So 50 times 90 degree means now for the nearest whole number, which is closest to 50 and is a multiple of 50, is going to be 48. So if we have 48 times 90, so 48 is going to lie in the fourth quadrant. Then 49 is going to lie in the first quadrant, and 50 is going to lie in the second quadrant. But we are adding 30 degrees to it, which will take us to the fourth quadrant. Now in the fourth quadrant, so that means 50 times 90 degree plus 30 degree is going to lie in the third quadrant, where tangent and cotangent are positive, everything else is negative. So that means our final value is going to be negative 1 over 2. So this is how we can obtain the value of the given trigonometric ratios whenever we have our angles greater than 360 degrees in each case.